This is a screenshot of a program that we're going to use in class for an in-class activity, and it shows a visual way of how an AND gate works. So here you have the AND gate represented by this kind of big D-shaped thing, and it has inputs, and these inputs are represented by a light switch, which is either off or on. Now the light switches in this program follow an unusual convention, maybe it's an Australian down under convention, where up means off and down means on. And so if the switch is completely white, that means the switch is off. And if the switch is blue, it means the switch is on. And so you just have to keep that in mind when you use this program. Other than that, it's fairly straightforward. And what I've shown here is four different options, four different ways that you can feed inputs into an AND gate. The first one is you can make both inputs be 0. So this means this input is 0, and this input is 0. And then following the rules of a logic gate, of the AND logic gate, it means that the output is going to be 0. Here the input is 0. Here the input is 1. And according to the logic gate table, that means the output is going to be 0. And that's represented by this light not being on. It means 0 means there's no power going to the light. This is another row, the third row in the logic table for an AND gate, which is essentially the reverse of this. Now the top one is on, the bottom one is off. And then when we put both switches on, now we have 1 and 1 here. Now we get an output of 1. And that's represented by the light bulb turning on. And so what we're going to do is explore in this class how to configure different logic gates and try to build up more complex things with really simple pieces. And this is the amazing thing about computation, is that most of what you do is built up on something that follows very, very simple rules.